All right, let's talk about how we walk through or traverse a tree data structure. With the linked list, it was pretty clear because we just started at the head and walked from left to right to right to right to right, and eventually we got to the end. But through a tree, there's many possible paths that I can take. And so I want to talk about 3 standard ways of visiting all of the nodes in a tree. The first one I'm going to talk about is the in-order traversal. It's perhaps the most used. And the intuition is follows. I'm going to draw a picture to show you what we want to do. So if you take your pencil and you kind of start to the left of the tree, and then you kind of draw along the boundary here. See this? So I'm going to keep going along the boundary until eventually I've gone around the whole thing. This is the order that we're going to visit the nodes. And you'll see I came up with a very intentional numbering of the nodes here. So I visit 3, 7, 8, 9, 10, 12, 13, 14, 15, 20. So see, they actually came back in sorted order. What I did was I made sure that the left child always had a value less than the node, and that the right child always had a value greater than the node. And when I did that, it turned out that this in-order traversal would actually would visit the values in sorted order. We'll talk about this more on Tuesday when we talk about binary search trees. So if you construct your tree this way, you can actually sort things very easily and you can look them up very quickly. But today we're just going to focus on doing the traversal this way. So how can I write a program to visit them in this order? It seems like I can do it visually myself, but how do I write code that does this same thing? So somehow I'm going to want to go to the left first, and then I'm going to visit my thing, then I'm going to go to the right, and then I'm finished. So I can actually define this procedure recursively. So if you look at it, so what I've done is I've drawn a path through the nodes, right? The path doesn't follow these arrows, but I've made my own path. So I've gone, through all the nodes by the time I get to the end. And what I see is that path is going to visit the left subtree of the root first. Then it's going to visit the root, then it's going to visit the right subtree. Okay, what does it do when it visits the left subtree? Well, it visits the left subtree of that subtree first, and then it visits the right subtree of that subtree. Okay, so it seems complicated, but we can actually break it down pretty simply if we think about it recursively. So the idea is you're going to visit all the stuff on the left first, then you're going to visit the node, then you're going to visit all the stuff on the right. So let me just try to define a recursive function to do that. So I'll call it Inorder. It takes a node as a parameter. And the first thing it does is it does Inorder on everything on the left. Okay, once it's done that, it prints out the node. So we're going to print out the nodes in this version. We're just going to print out the nodes in the order that they're visited. Okay, once that's done, I'm going to do the same thing on the right. That's it. This thing that seemed kind of complicated, like how do I actually get the code to do that? Turns out it's really this simple. I just break it down recursively. I say I'm going to draw the left stuff first, then I'm going to draw the node itself, and then I'm going to draw the right stuff. So let's look at that on this example. So I'll just use, in place of the nodes, I'll just use their values to keep it simple. So I'll say in order of 10. Well, first thing I do is I say, what's the in order of 10's left child? Well, it's in order of 7. And then, eventually that's going to stop, and I'm going to print 10. And then I'm going to do in order of the thing to the right of it, right? But before I do the print, I actually have to finish in order of 7, right? This is a recursive call. It's going to finish itself first. So in order of 7, well, there's a left child and a right child. So I'm going to do in order of 3. Eventually, I'm going to print 7. And then I'm going to do in order of 9. Okay, but before I can print 7, I have to go down to 3. So in order of 3, now 3 doesn't have a left child or a right child, so I can actually stop here and just print 3. Okay. Now I back up and I print 7, and then I do in order of 9. Okay, so 9 has a left child. So I say in order of 8. Then I'm going to print 9. 9 does not have a right child, so I don't recurse there. So if I'm being a little more specific here, I should say if node.left is not null, then you do this. And same thing with right. If node.right not null. Okay, so this is truly all the steps that you have to do. Okay, anyway, so let's keep going. So I've gotten to a node here so I was trying to do in order of 9. 9 had a left child, but it did not have a right child. So I just didn't draw the arrows here. It just means it's null. Okay, so I go to in order 8. 8 doesn't have any children, so I just print 8. Then I back up. I'm back in order of 9 again. I print 9. 9 doesn't have a right child, so I back up here. I print 10, and now I can expand in order 15. All right, so let's look at what I've done so far. So I've gone through, I said in order 10, and went 10, 7, 3, and then I print 3. Then I back up to 7. I go 9, 8, print 9. And then I back all the way up to 10, print 10. So if you look at the order that things were printed, I print 3, 7, 8, 9, 10. So it's actually printing things out in order so far. And then you do a similar thing on the right subtree. So in order 15, well, 15 has 2 children, so I'll say in order on the left one first. In order on 12. Then I'll print 15. Then I'll say in order on 20. Okay, but I can't quite do that yet because in order 12 I have to expand that. So the code will actually finish in order of 12 first. In order of 12 doesn't have a right child, so we're just going to print 12. Sorry, 12 doesn't have a left child, so we're just going to print 12 here. So we don't do this part, we just go ahead and print it straight away. Now I'm going to say in order of 14. 14 has a left child, so I'm going to say in order 13. 13 has no children, so I'm just going to print 13. Now it's done. I back up. I print 14. 14 does not have a right child. We're done. Back up. Okay, 12 didn't have a left child, so we're done there. Back up. 15 has a right child, which is 20. 20 does not have any children of its own, so we just print it. Okay, so let's look. So print. Let's go in the order of the print statements here. So we print 3, 7, 8, 9, 10, 12, 13, 15, 20. So that did it. All right, so what I'd like you to do now is implement this in code, which should be pretty simple, actually. This is the cool thing about it. It seems complex until you break it down recursively and just say, like, look, I don't know what I'm going to do overall, but I know that if I'm looking at a subtree to the left, that everything in that subtree needs to be visited first. Then I visit this thing and I visit the subtree on the right. Okay, so that's all there is to Inorder traversal.